If you're someone who's looking to take the AP Calculus AB course, or just want to review the information before the AP test, then this video is for you. What I'll be doing is I'll be going over a graphic that I made that covers the structure of all the concepts that you'll be learning throughout the course. This is important because rather than going through each concept as a list item, you should be treating each concept as a certain piece to a puzzle that is part of a greater picture. And kind of visualizing that will help you understand the concept better. And I'll be leaving the graphic in the description for you to look at. So let's get started. At the start of the course, you'll be covering the introduction to the derivative. Now, these are probably the easiest concepts to learn within the course, but they are also the most important. This kind of sets the baseline for your entire calculus journey, and understanding these will really help you throughout the later concepts. Limits and continuity are the first thing you'll learn probably, and they will help us derive where the derivative comes from. Next, we have the graphical analysis, which you'll learn next. And this basically covers what the derivative tells us on a graph. Pretty simple. Then over to the left, we have differentiability, which is basically just the criteria that needs to be met that shows us if we're able to take the derivative. And then finding the tangent line is basically one way to help us visualize the derivative, and will also help us with approximations later in the course. So again, it's important that you understand these concepts very well now, otherwise you'll have a hard time with future concepts. So moving over to actually solving the derivative. Now you have the baseline for solving the derivative that you learned before, and now we are actually going to solve it. Up here, you're basically just going over all the rules, right? Solving it numerically by using the power rule, e to the x, ln x, trig rules, and the chain rule. And all the information that's here will likely be covered in the span of 1 or 2 months. This does take up a big chunk of your calculus journey. I put a star next to the chain rule because this is the one that is the most important, as it applies to all of these other rules. And by the way, these aren't the only rules, these are just the most important ones. And there's also the product and quotient rules, which I put separately because you'll be taking a little bit of time learning about those as well. But I do consider them as a little bit extraneous to these other important ones. So after that, we won't be moving down there yet. You have the function analysis. So this is basically going to expand on your baseline that you set on your graphical understanding of the derivative. This will include the second derivative as well. This, I think, is a concept that students struggle with a lot, but it should be something that you understand well with enough practice. And down here, we have motion problems. These are just the graphical analysis, the function analysis problems. They're just applications of those. So if you have a good understanding of function analysis, you should have a good understanding of motion problems. Then we have implicit differentiation. This is a little bit separate from everything else in that this is a different way to do calculus, so to speak. So implicit differentiation isn't very hard, but again, I advise that you really lock this in your head as a skill set, because this will be important later on in your calculus journey. So then over here, moving back, we have related rates. Now within this big section, I'd say this is something that students struggle with a lot. You'll probably be faced with one of these in the AP tests, but what these are basically applications of what you learned throughout the throughout your content in the derivative. And the reason that students struggle with these the most is because what you learn cannot be applied to all of the problems. It's kind of like physics in that way, in that all the problems are different and they have their own unique ways of solving it. So there's no way that you're going to be able to understand them without practicing all of the scenarios. So this is the most difficult, but if you have practice, then you should not worry. Then over here, I put off to the side some other extra concepts that you might be learning, and these are MVT and EVT, AROC and IROC. So mean value theorem and extreme value theorem. That's just a short extra thing that you'll have to cover, but it's not too difficult, but it will definitely pop up on the AP test. Average rate of change and instantaneous rate of change. Again, it's not very difficult to understand, but it is important for the AP test if you are planning on doing that. Then there's linear approximation, which this goes back to the tangent line, where we use the tangent line to approximate y values on the graph. This is also extra, which is the reason I put it over here, and it's not very difficult. Then L'Hopital's rule. This will kind of help us identify limits. We'll be able to understand where a y value approaches as x approaches some value using what you learned from the derivative. Now, again, what you covered here is a big chunk of your calculus journey, right? Solving the derivative, and what you'll be learning next is basically the opposite of solving the derivative. So hopefully you have a good understanding on everything there. Then we move down to integrals, or you could call them antiderivative. So integrals, just an introduction to them, if you don't know what they are, is just you're finding the area under the line. So you'll be starting off integrals by learning about Riemann sums, and this is just a way to approximate the area under the graph using small subsections, basically. And then this should say anti-differentiation and integration rules. I don't know what happened there, but basically you'll be learning the same thing that you learned up here with all the derivative rules, just reversed. If you have a good understanding of these, then the anti-differentiation rules shouldn't be too hard. They are a little bit more difficult because there is a little bit more that you have to consider when taking the antiderivative, but again, with everything that all the concepts that you cover, enough practice should allow you to have a good understanding. So then after that, we have U sub and the reverse chain rule. I think this is very difficult. This is just the chain rule that you learned up when you learned the derivative, but reversed. And this is a little bit more complicated for students when they first learn it, but again, enough practice will give you a good understanding. Then after that, we have the fundamental theorem of calculus. And I think this is probably the most important part of this whole subsection. And this basically talks about what the integral means exactly. And learning this concept well will be a big part of learning, of continuing your subsection in integrals, as well as continuing series if you are planning to take AP Calculus BC. So this concept isn't very hard to learn, but it is very important. So I recommend that you pay close attention to this topic. Then if we move up here, we move on to differential equations and slope fields. Now, this kind of builds on your understanding of implicit differentiation up here, and it's basically using integrals to, it's applying integrals to this other way of calculus. So differential equations, if you have a good understanding of integrals, then it isn't too difficult. And then connected to that, we have slope fields, which This is basically just another way to interpret differential equations just on a graph. Yeah. And down here you have the area between curves and volumes of cross sections and revolution. These can be tricky just in memorizing the forms. But basically what this talks about is finding the area between a curve, as it says in its name, and then coming up with 3D shapes using that area, right? So I'd say in relation to everything else, this is not very difficult for you to learn, but it almost always pops up on AP tests, so I recommend you have these down. And that's about it. So there's the entire structure of the AB Calculus AP course, and eventually I'll have a link to all of these videos that will cover each concept in depth so that you'll be prepared to take the AP test. But for now, I hope this graphic was helpful to you. If you have any questions, you can leave them in the comments below. And thanks for watching.